Okay, question 12. We have a fiber optic question. So it's on a chapter of light. So it says that light is transported on a fiber optic cable. So it's finally converted to electrical energy. Fiber optic used in broadband internet applications. High bandwidth, lossless signals are important. Okay, so the most basic optic fiber consists of an inner cylinder, okay, called the core, the okay, the middle cylinder called the cladding. So this is the inner cylinder, which we call the core. We have a middle cylinder, which we call the cladding. So this is the middle cylinder, and the outer protective. So this is the outer protective. Okay. Now, if you look at the way how fiber optic works, the light ray comes in, it will bend towards a normal, it will travel like this. Now, if it exits, then the signal will be lost. So most probably how fiber optic works is that the light will just keep bouncing within it, okay, such that it will be passed down all the way through the cable. So several materials are used for making fiber optic. Refractive indices of these materials are shown. Okay. Now in figure 12.2 it says complete the path of light ray to show how the light travels through the fiber optic. So to that most probably this will have total internal reflection. So we need to draw the normal. Let me draw it properly. Sorry, it should be okay. Let's draw it normal like this. Then to show that the angle of incidence equals to angle of reflection, we'll draw the light ray like this. Okay. Then it will strike this surface, it will bounce off again. Yes, and it will carry on. Okay, so this is how the light ray will travel through the fiber optic. It will just keep reflecting within it. Now, part B define what is meant by the term critical angle. You can find this definition in your textbook. So but I'm just going to write down the textbook definition. So critical angle C. Okay, so the critical angle is defined as the angle of incidence. So critical angle is an angle of incidence, okay, in an optically denser medium for which the angle of refraction in the optically less dense medium is 90 degrees. Okay, so how it actually looks is this. Okay, so imagine a surface, this is denser, this is less dense. So this is normal. When the light ray comes in, okay, it will travel along the boundary here, and this is 90 degrees. Okay, now calculate the critical angle for crown glass. So we know that n equals to 1 over sine c. So this is the formula. So we know that for crown glass, the refractive index is 1.53. So 1.53 is equals to 1 over sine c. So sine c equals to 1 over 1.53. C is equals to sine, arcsine, okay, 1 over 1.53. So what you're going to get is 40.813. Okay, for angles in the theory paper, always leave it to whole number. So 41 degrees. So that's the critical angle, 41 degrees. Now, they say state the material in the table below which will undergo total internal reflection most readily. Explain your answer. So for the light ray to undergo total internal reflection most readily, okay, it will be dense film glass. Why? Okay, because the higher the refractive index, will the higher the refractive index, comma, okay, not will, the higher the refractive index, comma, the lower the critical angle. Why not lower, the smaller the critical angle. Hence, comma, dense flint glass will have the smallest critical angle. Hence, total internal reflection will occur more easily, more readily, sorry. Okay, next. Suggest a factor that would determine suitable materials for the cladding and the core. Okay, so the factor that would be important for this tool will be the optical density. Okay, optical density. This will be an important factor. Now explain your answer in E part 1. Okay, for total internal reflection to occur, for total internal reflection to occur, okay, light ray must be traveling from an optically denser medium to an optically less dense medium. Okay, optically less dense medium. Hence, the cladding, which is the outer layer, must be optically less dense than the core. Okay, so that will be the factor to determine the suitable material. State 2 advantages of using fiber optics over the use of copper wires in telecommunication. Okay, first, I would say that most probably is in terms of copper wires, okay, with current flowing will cause heating, which increases the resistance, hence energy lost. While fiber optics, let me erase fiber optics, okay, will not experience such issue. Okay, secondly, okay, fiber optics is a fast way for signal transmission, as light travels at 3 times 10 to the power 8 meter per second. Okay, hence signals will be faster than in copper wire. Okay, so this will mark the end for question 12.